Uh, is it visible?
Yes, sir.
Okay, thank you. So let me start with a small presentation on R, just to for if there are some participants who are completely new to R. I just want to give some short introduction to R. Okay, so what is R? So R is a dialect of S. A dialect in a computer programming paradigm or in a software paradigm, a dialect means a particular version of R. So the next obvious question is, what is S? So S is another software developed by John Chambers and others at Alt Bell Telephonic Laboratories, which was a part of AT&T Corporation, for their internal statistical analysis. But one of the key limitations, I mean, there was not much development in the S language from 1998. So, and one of the limitations is that S is only available as a commercial package, which is now called as S plus, because S plus is a kind of 2.0 version of the previous earlier S. So it's called plus. So the R software first appeared in 1991, and it was developed by two people, Ross Ihaka and Robert Gentleman. And the R software is named after their first name, for the Ross and Robert, in the Department of Statistics at the University of Auckland. And if some of you are interested to look into their experience of developing the R, it is being well documented in the cited paper. And but the R was first announced to the public in 1993. And in 1995, this was made free software under GNU or new license. Then there are some historical development in which actually the first release of R came out in 2000 as R version 1.4.0. And the latest version was released on 10th of August 2021. So it is R version 4.1.1. And there are some basic features of the R. So it can run on almost any standard computing platforms, like it can run on Windows, Linux, Mac, or any Unix, any software. And also it can be installed in tablets, phones, even PlayStations. And I mean, since the community is very, it's a staggering the size of the community, and very, active community. They have the very frequent releases of R. I think in every year, at least 4 releases are there for R in every 3 months. So this was a second release this year. And so actually, the frequent release means that there is an active development. And one of the important feature of R is that it's quite a lean software. It means that if you look into other software, like for example, if you know about MATLAB, it is one of the software used actively used in the numerical computation. The entire download of the software is around the latest one, maybe it's 2021 beta version is around more than 20 GBs, and you need, I mean, so much of space to install. But the latest version of R is just less than 100 MBs. So the one good thing about the R is everything is not just put in the R environment. They have the database called CRAN, C-R-A-N, and where these people, the developers, they come out with the packages in R which we use for statistical analysis, and we can download and install the packages as and when it is required. Okay, so yeah, and R obviously has a very good graphics capabilities. So this is just what do you mean by free software. So R being a free software gives you the freedom to run the program for any purpose, monetary purpose, or even for a research purpose or any purpose. And you have the freedom to study how the program works, for which you need the source code, and the source code is available within the R database. And you have the freedom to redistribute this software, so that your friends can learn about it. And you have the freedom to improve the program and release your improvements to the public, so that the whole community benefits. Okay, so as with the merits, there are some demerits in R. The first one is the functionality is based on the consumer demand and the user contribution. So if nobody has already implemented what you want to do, it's your job to implement it. So that is one of the drawback, but that is no more a drawback because of the active development community. I mean, every now and then, a lot of packages are coming out. If any package you can think about, I think it's already available in the archive. And yeah, the packages and modules are not authenticated because it's a free software, but there are certain rules. If you want to, come out with a new package or library in R, you have to, it has to undergo some test and, kind of thing so that it can be finally put out into the R, database. And this is actually the third point is one of the actual, drawback in R, because R is known as an object-oriented language, which I will let you know what when I share my R screen. And since it's an object-oriented language and it uses a physical memory here means a RAM. So even if with an 8 GB RAM, you sometimes, if you're working on some huge data like genomic data, you may sometimes run out of the memory. And you may find it difficult even to open the objects in the R environment. And most of the times you would go on crash your system, and so you need to rely on some parallel computing system or any supercomputer clusters for doing such big analysis. Obviously, it is not ideal for all possible solution situations. So R is primarily developed for the statistical data analysis. So that is the main purpose of the R software, even though it can be used for many general purposes, but it was developed for this purpose. So if you look into the R system, there are two, you can divide the R into two conceptual part. One is base R, which you download from the comprehensive R archive network. That's what CRI and CRAN stands for, and which is what I told, less than 100 MB, download. So that is your R system, and it's called the base R. And rest everything you'll have to download it separately as and when you require it. The base R system contains, among other things, the base packages, which actually there are many small packages which comes with the default download, like utils, stats, databases, graphics. All we will look into some of these, packages, and there are some other recommended packages also which comes with the base download. Okay, so this data actually yesterday I was looking into how the number of different packages available in the CRAN. So it is 17,966 packages are available in CRAN as of yesterday. So these many different packages are available. In 2015, it was just 4,000 packages. So R became public in 2000 to 2015, only 44,000 packages. And in last 5 or 6 years, you can see the how many fold increase in the number of packages available for R. And so there are also packages associated with the bioconductor project for the bioinformatics and genomic analysis. It's a separate project, and there are so many packages for R to facilitate those. So these are some of the documentations available to learn about R in the CRAN. I mean, these are all standard documentations available in the in their website. Okay, but if you want to really learn about something, it's all, I mean, internet is having such a huge resource, and anything you type in about R, you'll get a hit. And these are some of the standard textbooks. Okay, so I hope you might have already downloaded and installed the R. So this is actually, if you the standard way of downloading is go into this network, this website, cran.rproject.org. And you select your operating system and download. So mine is Windows, so I downloaded the Windows version, and you need a base one, so the base package of R. So you can click on and download it, and go to and download the latest version. Download R 4.1.1 for Windows. Oh, okay. So this is how your R looks like. I mean, this is your R software. This is actually your engine of the R, but we don't work with this particular interface because this is a very raw interface. Like you can compare it with something like your Windows command prompt or something. Like doesn't have much many user interfaces here. So but we have to download because everything in the R is contained within this particular thing. but we'll be using something called RStudio, which is a text editor. Okay, so there's some interesting facts about the R release names. You know, if you it's interesting if you look into the names of the releases of the R, the latest version, I mean, which is released, I mean, 2 days back. It's called the Kick Things, and all these names they take from the something called the, you know, peanut cartoons, peanut strips. Okay, so these are some of the names actually from the beginning, from some of the names which I could download from this particular you know, website, which I've given the reference underneath. And if you'd like to know about the naming conventions, there is a very beautiful video in YouTube. You can go and check out. And so they routinely update in Twitter and other social media platform about the releases. This is Peter Dargard. He's a professor in statistics, and he's in the R core team. I mean, I think he's heading that. And he routinely in August, and he tweeted about the latest release of the R called the Kick Things. And the Kick Things came from this particular peanut strip, you know, so where they speak about, you know, I just like to kick things. Okay, so that's how they name the R software, versions of the software. Okay, so about RStudio. RStudio is just a text editor. Basically, it's called an integrated development environment, IDE. So anyone familiar with the programming languages, they know what is an IDE means. IDE is somewhere you can write the program, save the program, edit the program, and there are a lot of user-friendly, you know, applications and widgets and kind of things in the RStudio. In an IDE. So there are a lot of IDEs. Jupyter is another IDE. Sorry, Spider is an IDE used for the you know, Python. Then you have Notepad, Notepad++. Lot of IDEs are available, but RStudio is the one which is suitably made for the R. So it's a nice text editor with syntax highlighting. We'll be looking into those, and there are object viewers and a number of nice features that are integrated. So basically, RStudio makes our life easy to work with R. Okay, so this is how to install R. So we want this to download this free version of the RStudio. And okay, I hope you have already downloaded and installed. So okay, so this is how an RStudio looks like, you know, the programming environment. So I'll explain once I just share my screen. So there are made for Windows here. I'll explain when I share that. Okay, so finally, the philosophy of the R. Our philosophy is the gradual transition from a user mode to the developer mode. If you look into the roots of the this particular programming language, it is different from any other traditional languages, like the general purpose programming languages. If you look into C, C++, Java, JavaScript, any of those languages, you need to have a very firm idea of how the programming language works. But in this case, without any prerequisite, you can start working on R. So it was primarily made for the data science purposes and statistical analysis. So the developers, they wanted any beginner to start learning R and use the you know, R for you know, their data science works, and gradually shifting them from as a user to the developer. Like once you get you know, comfortable with the R, the environment and how it's work and the internals of the R engine, then you can move to the developer mode. Okay, so this is the best software to start with, actually. I mean, if you want, if your idea is numerical computation or, you know, a statistical analysis. Okay, thank you. So that was just a presentation. I'll just to introduce, I'll just share my you know, RStudio window. Okay. I hope I'm still audible and my screen is visible. Hello, am I audible?
Screen is visible.
Am I audible properly?
Yeah, you are audible also.
Okay, thank you. Okay, so I've just shared the screen from the RStudio. So okay, so the screen which you are looking into is known as the RStudio, and Okay, so
पहले जो ज्वाइनिंग में प्रॉब्लम आ रही थी, तो मेरे जो स्टूडेंट है उसने क्या करी, जो उसको लिंक आई थी ना, वो उसने ली और व्हाट्सएप.
yeah, thank you. So if you look into the the R Studio, so just don't get confused with R and R Studio. R is the actual software which we are downloading, and R Studio is just like a wrapper around the actual R, just to facilitate whatever work we want to do. Okay, so if you look into, if you think of it as two-dimensional partition plane, the upper left quadrant here, this particular thing is okay. Some of you might be actually, if you are downloading R for the first time, you may get it like this. I mean, you may not see the the editor window here, so just can click open here and the editor will appear here, or else otherwise you can open an R script. So okay, so this is the place where you write your programs. Okay, so this place is used for writing the programs and saving the programs and editing the programs. Okay, so once you write the program here and you highlight the program and click the run button, it will send it to the console. So this place, this console is called the this place is called the heart of the R. If you look into the console, there are some information. So at the beginning, you have the version of R, which is 4.1.1, and it's named as Quick Things. And there are some license information and citation information is there, how to cite the R. If you just copy and paste and it here and click the hit button, I mean enter button, return button, you're going to get the how to cite the R and things like that. Okay, fine. So in the right upper quadrant here, you can see a tab called environment. So environment tab is where actually whatever objects what you're creating, I'll in a little while I'll show how to create an object. So the objects will appear here, and so you have something called the next tab, which is called the history tab. So all your previous codes which you have used is gone will be displayed here. So there is another tab called connections. I mean, this is for the advanced users. If you want to connect to any database, relational databases, and you want to work, I mean, with some big data, so you're going to do it here. This is somewhere you can go to the tutorial. I mean, if you click the here, you can, yes, means if you click here, you can install the Leonard packages and many things associated. So what is important here is what you'll be using frequently will be the environment window. Okay, and if you see at the lower right quadrant, there are 1, 2, 3, 4, and 5 different tabs. The first tab is your file tab. File tab gives a location of your default directory. The default directory by default, once you install R, the default directory will be your documents. And the importance of default directory is whatever you're saving in the R, I mean in the system, not in the R. And one more thing, in the environment tab, okay, here whatever appears here will be saved in your physical memory. So that was one of the limitation of R. So it depends on how much you can store, depends on the your RAM. What is the memory? What is the capacity of your RAM? Okay, but whatever is stored here, they goes directly into your hard drive. And it is important to set the default working directory, which I'll show you in a while. So mostly, I mean, by default, it goes to documents, and but it's a good practice to set a different default directory when you start working with R. And this is a plot section. If you're plotting some diagrams, this will appear. The plot will appear here. You can export, zoom in, and save it as PDF or image. And then, okay, this is another important session, the package session, which we were talking about. Okay, so this is where we install, I mean, from this place where we install the packages. You can update the packages, you can load the packages, which we'll see in a while. And this is where you get the help. There are ways and means to, get help and awareness from just by typing in, command in the console. And this is a viewer plane if you're using the Markdown or the notebooks. And if you want to, there is a option called knitting in R. You want to knit, you can knit. Knit is just a jargon technical term used for, to converting it into PPT, PDF, Word document, or even HTML. You can have your own website just by, opening an R markdown. You can have the, interactive websites. Okay, so you have options in GitHub where you can host your own website, you write something, or some models or something, and you want to post, and some small chunks of programs. Okay, fine. So we look into some of the options in the okay. So here file option is there. What is important here is the import data set, savers, all these things. So we will import some data, and we will see how to import the data. And edit. Okay, there is another important is if you want to, okay, there is a global option where you can click in and change the options, the colors, and how it appears and things like that. Okay, so we'll see first how actually to set the default directory. Okay, before that, maybe we can start with some of the basic operations in R and how the R works. Okay. So I'll just go. So this is just a simple scripts I made for today's lecture. So if any of you, some of you might have an experience with the programming languages, and it's just a convention to start with, hello world program. I mean, print is a function used to print objects, or not objects, print the strings or thing or objects for that matter. And there are two things to be noted. One is a function, and one is library or the package. So you have a lot of libraries here. Okay, so for example, if I go to one library, ASRML. Okay, so ASRML is a library which is it's the same thing as ASRML standalone software, but recently they have come out with an R version for this. It's a paid one, and so this particular package is used for fitting the linear mixed models. And once you click in and go inside the package, you have bunch of information here. You have description star, you have a user guide, and you have the functions here. Okay, so for example, if you go to some function for fitting the mixed models, you will have the plot functions can be used for plotting, and so that's how it actually works. I mean, so you have the library and you have the function within the library. And this particular print function, it comes with the base package. If you remember from the presentation, I told you the base comes with some of the default packages like util, stats, and many more. So the print is one such function from the particular package. Maybe we can type in the console, and it should give you the library. Okay, see. So when I type in print, it gives all the a pop-up window having the keyword print. So we need the first. We're going to use this particular function called print, and which is from the base. So we can see here from the base package. Okay. So we are not going to type directly in the console, because R has another name which is known as an interpreter kind of language. Means once you type in a code to the console, it interprets it readily, unlike the traditional programming languages like C, where you have to write down everything and send it to the compiler, and compiler send it back. So it is a different kind of it uses it altogether different route. But this like R package, your Python, they are all interpreter kind of language, because once you type in immediately and click enter, it interprets the language. Okay, sorry, the script or the syntax. So this particular thing, we can call them scripts, code, syntax, or whatever you like to call. Okay, so we'll just see how, if you like to do along with me, you can open your RStudio and you can type in, you can open, a script from here. How to open a new script is, anywhere, you click anywhere, just click on this small, a widget seen here with a plus sign. I think, hope you can see this here. and click it down the drop down menu. You have the first option called the R script. Okay, you can click open the R script, the new script is open. And how to save this new script? Okay, so okay, this is my new script and I want to save it. So for that, I will just go to the files and change my default working directory. So how to change the default working directory? Let's see what is the current default current working directory. For that, there is a simple function in R called get WD. So get WD stands for get working directory. So it is going to give you the default working directory. Once you click here, you're going to get, okay, I will explain later what is this one and things like that. So it just gives you, just for the time being, just understand that the default working directory is C users admin and document, which would be the case with all of you. I mean, it must be the document. That is how default PR is set. So now I want to go and change these working directories so that whatever I save into the hard drive, it defaultly goes into the into my working directory where I want to do it actually, and this file will show up that particular folder. So you have an option here, 3 small dots at the right hand side. Okay, click open that, and you have the navigation window, and I have in the desktop I have a folder called R lecture, and I'll just click open it. So this C, it has changed. It took me to the this particular folder in C user admin desktop and R lecture. Okay, so you can see it here. This path is shown here. And now I want to set this as a default working directory. For that, R Studio is having an easy option for doing it. So you can see this small widget here called the more with this settings icon, and it's a drop down menu. Click on that. Click set as working directory. Okay, so now see what happens. It actually when I click that, it automatically send a code to the R console. Okay, which is set WD, means I'm asking the R to set the working directory as within the bracket. So this is how the syntax is like. Okay, so if you want to set a working directory, you need to type in set WD. Okay, and that bracket, any function would contain a bracket. Okay, so any function comes with a bracket, any function in R, whatever you want to do, you'll be writing within the R, and sorry, within a bracket, and whatever you're writing within the brackets, we call them as attributes, okay, of that particular function. So and this is one good thing about, if you are directly using R, actually the R software, I mean, rather than connecting with the R Studio, you'll have to type in everything like this. See, this makes this saves our time. Okay, and okay, so now it being set, just for saving it, I can just click Control and S, and it will directly open this particular folder. So I can just type in the name as hello world, and click save. So my script is saved here. Okay, and so now I can start writing my first program. Just start with the print function. I want to print the hello world. So I'll write print in brackets hello world. Okay. Okay. Don't get confused with the underscore. I just put an underscore there. What's important here is these two double inverted commas. See, if you don't put we'll just first run this program and see the result. Okay. Either you can just select it as such like this. Otherwise, you can click here on this number. So it will be like, it's a fourth line. So line will be highlighted with the numbers. So you just select this, and 2 ways you can run this. Either click the run button here, what you're seeing here, you can see the run button, and you look into the console has given you printed the hello world. Okay, so what will happen if we don't use the inverted commas? So I'll just remove the inverted commas, double inverted commas, and so an unexpected symbol. So that means in any function, if you give an inverted comma, okay, if you're not giving an inverted comma and writing anything inside the function, so R assumes it to be an object. We have not yet created an object, so you don't know what is an object, but it's important to say it here. So, okay. Another way of running is this, you keep your cursor at the end or at the beginning of, the script and just click your control enter together and it interpret the language. Interpret the syntax. So any doubts, anything? Can I continue like this? Hello, Sajid sir? Or you want to have an interaction here? Any doubts or? Hello. Oh, okay. I think, okay, you can continue. Thank you. Why fourth line? Okay, somebody was asking why the fourth line. I just because to make some space, I've clicked enter. That's it. No, you could have done it in the first line or the 100th line, no matter where you do it. Okay, thank you. I'll continue. Okay, so we'll move into some of the basic arithmetics in R. R can be used as a calculator and not very important, but just for information. So before going into that, we need to look into something called the operators, because we are using operators like plus, minus, multiplication and division. So there is a whole bunch of operators. If you can see this particular page here, okay, so it can be broadly divided into arithmetic, relational, logical, assignment, and miscellaneous one. So the arithmetic operators are very important. Very frequently you'll be using this plus symbol for addition, this subtraction, and the star symbol for your multiplication, this right slash for your division, this for your finding the modulus or remainder, then it is for raising to the power. So this is important, the plus, minus, multiplication, division, and to the power. Okay, so just remember how to raise a number to its power. Use this particular symbol. Okay, and so relational databases are required if you go into beta advanced things like greater than equal to. And one thing I want to tell you here, see this double equal to. Okay, so and here it is a single equal to. So there is a difference between double equal to and single equal to. So equal to in a programming language or in R specifically means that you are assigning a memory. If you are we'll be using it when you create an object, you will put a symbol equal to. You are assigning a memory space to that particular object. That is what it means. And these are assigned symbols less than dash equal to, double less than. So I'll just show you right away. And this is for like this is to is important, because if you want to generate a sequence, like say for example from 1 to 100, you can just write 1 is to 100 and it gives all the numbers all the way from 1 up to 100. So this percentage is not be using it right now, but if you want to go through all the elements in a vector, you use that. So this is important if you're using some matrix algebra. This is for the cross product of the two matrices. The percentage is very often we might use, if you're into these things. So this is operator. So we'll just right away go into the arithmetic. So remember, it is always a good practice to start writing script within the editor, because once you can do the same things in the console also. So here you have 5 plus 9, and if you run that, you have to get the answer is 14 here. The same, see, once I run, you need to look into the console here. Okay, the same thing you can write in here. 5 plus 9 is 14. Okay, so same way subtraction, 5 plus minus 9 should give you minus 4. And I'm not going to waste much time on all these things. So multiplication. So just to make you familiarize with these operators only, I'm just saying all these things. So 10 times 8, you have 80. And division. Okay, this is important. 123 upon 86 gives answer. And this thing I've wrote here just to make you familiarize with that the order of precedence, if you're using the brackets, the multiplication, the addition, and the division, the order of preference is the same order of preference what we have learned in our high schools. Okay, so you can just type in and go back and look into these things. Okay, the next one is the exponentials. So I just shown you this small symbol, okay, which is to the power. It means 2 to the power 5 and gives 32. So 200 to the power 50. So see how fast things it gives you the answer. So 200 to the power of 50, it is given in scientific notations, 1.259 into e to the power means 10 to the power 115. That is the answer. So it's like 115 zeros after that. Okay, so fine. Let's see what give 0, something rise to 0, 0, 0 rise to 1. So 1 to the power 0, 0. Okay, so now we will use the find the square root of any number. Okay, SQRT is a function which is a very handy function used for finding out the square root. Why I'm saying is that because sometimes when you do the data wrangling or data manipulation, and if you want to do some kind of conversions from one scale to another, most often we convert from our regular scale to the square root transformations. I mean, you do a square root transformation, you do log transformation. So that time you need to know what are the functions to be used. So if you write SQRT and within the bracket a number, it should give the square root. Square root of 4 is 2. Okay, so you just run, once I run, just please see the console for the answer, and you're gonna get results. Okay, fine. So we'll move to the logarithms. Okay, just see. So this is one good thing. I mean, this language, I mean, the high-level languages which we call, they use the same notations and the language similar to the regular language, the English language which we use. I mean, if you want to find out the logarithm of any number, it's just the log, and within the bracket, you need to give the number. So this log of 100 should give you the natural logarithm. So natural logarithm is a log to the base e. So e is 2.71828. So let's see what is the answer for log 100 to the base e. Fine, it is 4.60517 is the answer. So yeah, the meaning of log means if you find a log and the answer to the log when raised to the base, it should give the 100. Okay, let's see if we get that thing, because this is actually 2.71828 is the Euler's number, which we called as a E. So if you want to see that exp, you type in exp, and if you want, you're going to get 2.71828, which we call also Euler's number. So 4.60517 is the answer to the log 100 to the base e, and so the base e when raised to the answer should get 100. See, you're getting the answer. Okay, so that's it. Any doubt there? Any clarifications? Are we good to go? I know I'm going a bit fast. I'm speaking a bit fast because otherwise we'll not be able to cover the portions. So if anything, you can stop me and ask.
There is one question, Doctor.
Yes, sir, please.
How to use results as a new file for analysis?
Okay, we'll go to that. Results is a new file. Oh, yeah, that's okay.
Another person is asking that from where these square root and other commands were brought.
Okay, fine. So if you remember my presentation, I told the base R package. Okay, so just to appreciate that, I mean, where it comes from, you can try typing in the console. So just type SQR and T. So see, you can see if you look at the left bottom quadrant. So here you got a pop-up window showing the keyword SQRT, and in the curly bracket you can see base. Okay, so if you click on that, I mean, not just click, I mean, it gives a small window showing a small documentation. So this particular SQRT comes from the base package. We don't have to call a package because it already comes with the default download of the R software. Okay. So you type in SQRT, given a number, should give you the result. Okay, so many such basic functions will be mostly concentrating on the base functions only today. Okay, they comes from the base R. And the next question was how we save the results for next analysis. Okay, that's where our objects comes in. Okay, next is your how to create an object. So if you just simply type in 2 plus 2, you're going to get the result 4. But what if you want to store the result 4 into an object? Okay. So instead of just typing in 2 plus 2, I want to store the answer of 2 plus 2 into an object. So here, if you look into, okay, okay, so I've written ANS1. So ANS1 is just a name I've given just to, this is our first result which we are storing. So ANS for answer 1. Okay, so you can write any name there. So how to name the objects before creating the object, we'll just see how to name the conventions for naming the objects. So there is another window here. So there are many conventions for naming the objects, and there are some valid conventions and invalid conventions. Okay, so if you look, I've given some. So this is variable underscore. So these are various ways in which you can name. So variables, instead of variable, you can have your name, you can have any name, you can possibly anything you can think about. I can have Rameez underscore name, Rameez underscore Roshan, 200, anything. So whether that is valid. If I say Rameez underscore Roshan and 2, yes, it is valid. Okay. What is not invalid is if I just write Rameez underscore Rameez and after that I put this special character for percentage, it is invalid. So see, all these things you may find bit complicated, but it's not very complicated. I mean, just for your, if you like to look into these things further, I mean, you can simply give, sometimes you may have to give dots or underscores when you're creating the objects, many objects you're creating, and recurrently you're doing something. So at that time only you may need to go into such complex naming things. So the point is, if you put a percentage after any name, it's not valid, it's invalid. So what they say is only a dot and underscore are allowed in your object name. Okay, so if the name starts with a number, it is invalid. It cannot start with a number. Okay, and if it starts with a dot, a name starts with a dot, like a dot Rameez, and I'm assigning some result, it is valid. Okay, and if a dot comes in the middle, it's valid. But if starts with a dot and then with a number, it's not valid. Okay, and if it starts with an underscore, it is not valid. It has to be in the middle or maybe at the last. Okay, so I think that's enough for the naming convention. So we can have very simple names for today. So I'll write something called answer 1, and I want to store the results 4 into that particular object. So I'll just run that. Okay, now see the console. I don't get an answer here. Just I'm seeing the script. Okay, and the object what we created, if you look at the environment tab here, okay, at the upper right quadrant, you see answer 1. Okay, so if you look, you may be seeing something different, like you may be seeing this view. This is the default view, which is called the list view. But at the right hand side, if you go to this particular widget and and drop down the menu and change the grid view is actually good because it gives you different the types of the data and things which I will discuss a bit later. Okay, when we import the data, so it gives a length. Okay, whether the length of the vector, because it's automatically being created as a vector with a single entry. You can call it a scalar or a vector, and as a size, how many bits or bytes it has, and the value. Okay, so there is actually if you'd like to delete this particular object, so this object, it is being stored in your RAM. Okay, so if you create some 100 objects like this, maybe your RAM might overrun, and it's this small thing, if you see that, which is showing MIB is not actually the megabytes, it's the maybe bytes, but almost similar. 1 MIB is equal to 1.0 megabytes. So it's almost similar. You can think 181 megabytes only are being used. Okay, so if you drop it down, you can get some options here. Fine. The important thing is how to delete this. If you want to delete this particular object, you check this, check mark this. Okay, and you can see this small broomstick here for cleaning. You click on that. Are you sure want to remove one object from the environment? This operation cannot be undone. Yes, I want to remove. So I've cleared my environment. Okay, and these objects, when if I sign out of R, these objects will be stored in the R environment unless you remove it. Okay, so the one good thing about setting a default directory is that in different default directory, if you're quitting R from the default directory, the objects will be saved in that particular default directory. Okay, so it is so when you go to advanced programming, and if you want to do many analysis, and if you have later on, you'll not get confused which objects is stored in which one if you are rightly numbering the folders. Okay, so this is how we do it. So here what we does is I'm asking the R to calculate 2 plus 2 and store the result into the answer 1 object, means named as, this object is named as answer 1, and I'm assigning a particular memory in the RAM to store this. So another operator, I mean, even though equal to is used, there is some advantage in using this advanced assignment operator, which is less than and dash. Okay, so it will give you the same results if you run this one. Okay, it's going to give you the same result. And how you're going to get the result stored in this particular object? Either, I mean, you can use of course use a print command, and without the inverted commas. If you remember, I told you if you're using a double inverted commas, see what will happen. Double inverted commas, so it takes it as a string or a text or a character. Okay, we'll see that. And just if I'm, so it will just print answer 1 instead of the result. But if I'm not using these double inverted commas, so I'm asking the R, and R will assume ANS1 to be an object already created and stored in the environment, and it will throw out the result contained within the answer 1. So just run it and see what happens. Okay, we got the answer which is stored inside the answer 1. Okay, which is 4. We don't have to use this print function every time because we are starting out with the programming language. Just as conventionally, I just told you the print. You just can simply write, send the answer 1 to the console. Okay, it gives the answer 4. And ANS, even you can type it. See, it appears here, as a vector. So fine. So that is how we can print, store the results in the R environment. And there are ways and writing. I mean, this is just one number. If you are dealing with huge data, I mean, there are options for writing it in the TXT file or Excel file and many other file format, CSV format, any other format. So the same way you can division. I don't think we should waste a lot of time in these things. Actually, fine. So the same way you can create an answer 2, and the results answer 2 means, sorry, you can divide 10 by 2 and store that answer in this particular object called answer 2. Don't get confused by saying answer 2. It can be any name. It can be your name. It can be any name which you can think about, but with some conventions which I've previously discussed, that you shouldn't be using starting it with a number. You can end it with a number, answer 2, but it will not take if you start it with 2 answer. Okay, so those are the things we should remember. And so as we created 2 objects, answer 1 and answer 2, right hand side you can see the upper right quadrant. The 2 objects are saved here, and if you can operate on these 2 objects. In fact, if they are coils, I mean, this object, they are compatible with each other, you can use them for to use the operators and do mathematical functionalities and store it in a different object. So I can, now I know the answer 1 has some value, answer 2 has some value, and I want to sum over them and create another object called answer 3. Okay. Okay, another object is created, And let's see what is within answer 3. It is should be 9, which is 5 plus 4. Okay. Fine. So this is another way of assigning the result. Okay. Less than and dash, and I would recommend you all to use this particular symbol because we'll in the next 3 lines we will see why we have to use it. Okay. I've just did a summation of 9 plus 6 and stored inside answer 3. Yes. So what is important is you can rewrite an object. That is why actually I made this. So we already had something stored inside the answer 3, which was cells in answer 1 and answer 2. And it was 9. And now if in the right hand side, you can see the value here is 9 within answer 3. But what if you want to rewrite it? You can use the same object name and assign another operation and save those results into the object. Okay, so you got an instead of 9, now the object name is same, but the value has changed. Fine. Okay, so now you can operate on numbers as well as objects. If you're an object and the object has the compatible values with these numbers and numerics, so you can use it, and you can assign it to the right hand side. So when you assign it to the right hand side, instead of the left less than and dash, you can use a dash and greater than. I mean pointing towards the object of at the right hand side. Okay, so it's answer 3 plus 5 plus 4 minus 2. So answer 3 has, answer 3 means object answer 3, it has already have the value 15. So I'm asking this particular line to do 15 plus 5 plus 4 minus 2, which should give you answer 4. Okay, so what is why we should use this less than or equal to simple, sorry, the less than or dash is that okay, if you are giving the object name at the right hand side, many times you would need, if you are using the control structures and loops and all, and many times you would run into such a scenario where you have to give the name at the right hand side. So that time this equal to symbol will not work. Okay, see, if you are giving the equal to symbol, equal to and the right hand side the object name, it will not work. So the better is to start using the convention left hand less than and hyphen or dash and greater than for a left hand assignment and right hand assignment. All right, so any doubts there?
Doctor, we will take the doubts at the end of the session.
Okay, fine. Okay, so now I know many of you must be waiting to get into the statistical part, but if you're new to R without knowing these things, you'll not be able to work further. That's why I'm just trying to explain all this. These are very basic things. So another thing is which you need to, before creating bigger data set, what you need to know is, data structure and data types. So we'll do one thing, we'll straight away go into the importing the data. So before importing the data, you need to know how the data is stored inside the R environment. Once you import a data set, the right hand side of the environment side will show the the data here. But depending upon the nature of the data, it will be stored in different ways. So there are 1, 2, 3, 4, and 5 different data structures. The different ways in which you store the data within the R environment based on the increasing complexity of the data. The very basic kind of data is known as vector. There is a reason for calling as an atomic vector, which we are not concerned right now. Just think vector in a computational paradigm. A vector is an array of number. Any number array in a column or a row we call it a vector. The same vectors which it's the same as it's in a more lower level, in more abstraction. It can be think about as a dot in higher dimensions or the arrows in the space. It's all same, but here they are just the numbers. Okay, a column of numbers or row of numbers is called a vector. So if you import a column of number, and that will be imported as a vector. Second, so and the most important thing is it is one-dimensional data. There will be just a column or otherwise a row. Okay, so if you have multiple columns of the numerical data, R will import it in the form of a matrix. So it is a two-dimensional data set. Okay, so and the constraints are that it should be it has to be of the same the two columns has to be of the same length, and everything has to be of the same it should contain only the numbers. Array is an n-dimensional matrix. Means you 3 or 4 or 5 the higher dimensional matrix is called I don't know, maybe some of you might be finding it difficult to understand the higher dimensional matrices. I mean, what we usually call in tensor. But yeah, if you go a little bit into the linear algebra, it will be easy for you to understand those paradigms. So anyway, the one which you'll be frequently using is called the data frame. So data frame, the easy way to think of data frame is your Excel data sheet. So Excel data sheet is imported as the data frames in the R environment. Sometimes the data frame is, R will call it as a data frame, or sometimes it may call it as a table. Okay, depending on a small difference. Okay, so mostly I think in the newer versions, they call the data frame as a table. The difference is that the first three are the homogeneous data. It must contain only, it can contain only one type of the data, just numbers. Okay, but the data frame and the most complex form of data is called the list. So the list, in data frame also in the Excel data sheet, all the columns should be of same length. And but the columns can be of different types of the data. You can have the decimal, real numbers, complex, characters, anything. Integers, but in a list, you don't have to have the same column length. It can be a multi-dimensional data frame. Okay, so both of these, since they can contain the columns with different data types, they are known as the heterogeneous data, data structures. And within the data, like the basic form of data is a column or the row of numbers, okay, which are called the vectors. So within the data structure, there are different data types. One is character, another is numeric, integer, logical, and the complex. So most often we'll be dealing with the numeric data and the character data. The character most of the times will be, what is that, using for the ANOVA and the basic statistical analysis. We need to have the classification variables to classify the data. Okay. So integer, even if integers, integer we don't use it usually in the R, because sometimes if you have to, pipeline the data to other languages like the Fortran, I mean, it's a prerequisite that we should convert the even to the numeric value to the integers. Okay, don't have to worry about the rest of things. So maybe we can start importing the data right now. Or okay, maybe before importing the data, I just would like to show a couple of more things here, which is how to create a vector. Fine. See, I've mentioned here creating small data set, entering a numerical data. See, data one, I've named this particular thing as the data one. I'll explain what this thing is. So once I send this to the console, it will create an object called the data one. Okay, and this particular function, the smallest function, I mean the C function, C is known as the concatenation function because it concatenates numbers and gives you a vector. So this is what I call as the column or the row of vector numbers. Okay, so if you send it to the console, you're going to get an object in the environment, which is named as data one here, and contains numbers, and the length of the numbers is 7. There are 7 different numbers, and so many bytes have been used, and numbers starting from 1 to 7 means 1 to 7. The numbers are from 1 to 7. And if you want to print, you just type in data 1. Okay, you see here at the bottom left quadrant, you got the results here. So the first number within the square brackets, it gives you the first element of the first line. Okay, the first element of indexing of the first element, not the first element, sorry, the indexing of the first element. So in the R, the indexing starts from 1. So the number 2 is at the position 1, number 5 is at the position 2, 8 is at the position 3, and all the way up to the 7th position we have 4. Okay, so that is how I mean, it is very important. In fact, you may, some of you may find it a redundant information, but it is a very important information when you go into some advanced programming. And unlike some other languages like Python starts its indexing from 0, but R starts it from 1. Okay, remember that. And if you have multiple lines, like, we can just try to print numbers from 1 to 100, 1 to 100. So I told you this particular operator, if you can see the left bottom quadrant, okay, this highlighted part, this is used for printing the sequence of numbers from 1 to any number. Okay, so this is a vector from 1 to 100, and this first the number in the square bracket gives the indexing of the first element of that line. Okay, this 21 is the same as 21 because previously there were 20 numbers, that's why. Okay, and so same way you can create and store into different what is that, names and environment, so we'll not be wasting much time there. And you can, the same way you can create what is that, is that just the name of some of the fish, and create text data. It's called a text data. Okay, so before moving into, let's see actually our data one. I said data one, what is the type of data one, what is the structure of data one? Maybe you can use str. Okay, str is a function which is used to find the structure of a particular data type. So data one, okay, it's a number. It will give you the data type, not the structure. Okay, data one, double number, double numerical precision numbers. And okay, so if I want to check if it is a vector or not, I can say is dot vector and data one. Yes, it is true. So this is how actually there are some very easy going functions in R. If you want to check is a character, is your character can be used, what is the type of the data type inside, you can use a function type of and give the name of the your that object inside. So there are many user-friendly functions there. And the same way, if you're creating this particular one, data 4, see, this is called a character vector. Okay, so the vector can be the numeric or otherwise character. So when you create a character vector, you need to use, you're using the same concatenation function C, and within the brackets, you're writing the character names within a double inverted commas. Otherwise, R expects it to be an already created object. Okay, so if you run this, you're going to get a character vector and just print it and the data 4. Okay, so you're going to get the result printed here, and the results are printed within double inverted commas because they are characters. Fine. So I think that is enough with the very basics. I mean, I have not covered any basics actually. I mean, if you can look into, there are a lot of things if you are really, interested into looking into the, internals of R and how the R works, because it gives you a lot of strength when you do, power when you do the programming. So let's go to the importing of the data, which is the most important part. Okay, so I think sir might have shared one file with you, just 50 raw data on some string data it was. So it has 3 variables, and so I'll show you how to actually import the data. So previously you had to write a function to import. Maybe 3 or 4 years back only they have included a function in RStudio, GUI function, graphical user interface function, to import the data. Okay, so now it's very easy to import the data within the R environment. So if you see in the upper left hand side in the file drop down menu, you click on the file drop down menu and go to the import data set. You have many 2 or 3 or couple of different options here. One is you import from the text data, one you import from the Excel data, and there are some advanced user like if you have SAS and SPSS, and if you want to connect and import from them. Okay, and there is from text read or also is there in the bracket. So the first one is for the text data, second one is for the comma separated value CSV file format, and third one is for your usual spreadsheet Excel file format. So why so many format is that? I mean, you have just a 50 row data and Excel file, it's well and good. It don't take much of the space. But if you have like tens or thousands of raw data, like huge data, or we call it big data, and if you want to import from the Excel, most of the times, depending upon your capacity of the RAM, your system crashes. So that time you need to save the data into as a text format data, or what we call ASCII format data. Okay, so anyway, just for time being, we'll do it from the Excel, and I'll show you both how to import this one. Okay, so I'll click open from Excel. So it is giving you one pop-up window. I hope you can see the window, or this pop-up window, and go to the browse. And in the default directory, I've saved it as example data. Open the example data. Okay, so there is a little preview here, and there are some of the things you should notice. I mean, you have got, there's a preview here, and preview there are 1, 2, 3, 4, and 5. The last column, if you keep, I mean, you will get the column number and the type of the data contained inside and the range of the data. I mean, in every column you're going to get. So first is for the factor. This is actually a classification factor, which is pound. And second is the sex of the animal, and this stands for maybe head length, total length, and the body width. So just some numerical data, just to show how these things work. Okay, and so if you go to look at the bottom part here, you have the name. So I've named this data set as example data in my origin location, so it is showing the default name. So I don't want this big data, big name in the name for my data. So I'll just write EX example, or EX1 means example 1 data. Okay, and just remember that the naming in R is case dependent. If you're giving capital E and small x, and you're trying to search for lowercase while you're working with R, you're not going to get that. You're not going to reach till that data. Okay, so just remember, always keep the name very simple, always in the lowercase letters, so that further it makes the things easy for you. So below that, you have got a sheet option, where if you have multiple sheet, that will be shown here. So sometimes you save the data in multiple sheet, like 10 sheets, and if you want to select any particular sheet, you have the option here, and you have an option for giving the range if you want to select some range, maximum rows. If you want to skip any any values, you can give that. And NA, there's an option for NA. We don't have any. NA stands for blank. I mean, there is missing values. Okay, so we don't have any missing values. So this default, by default, R assumes that we have a column head. Okay, or we have column labels, which is font, sex, HL, TL, and VW. And this option open a data viewer. Once I click the import button, and the data will open another viewer pane. So these are just the default, and this is the a function and the library that for importing the data in Excel file. R uses read Excel library. Previously, this library was not included in the base R, but now this library comes default with the base R. Previously, before importing, we had to go and download this particular package. Okay, and so this is, see here, if you see this particular line, I have given the name as EX1. So that is an object name for this particular data set, which is a data frame. And I'm giving a left assignment operator, less than or hash, which we discussed previously. And after that, I'm calling the function read.excel, which is a default function within the library read Excel, and giving the name within the inverted comma. So this is the automatically, we don't have to look into all these things, just to make you understand. So just import the data, and you're going to get data displayed in the viewer pane here. Okay, fine. So okay, if same way, if you want to import into with an TXT document, we can do that. So without much delay, we can go. Okay, fine. So now I will type in the console. Okay, so if you want to clear the console, the easy the key hotkey is to click Control and L. So it clears your console. I mean, it deletes nothing. You can get the retrieve the commands from the history pane over here, but it clears just the console. Okay. So I imported the data, and you can see the data here. Fine, EX1. It is a table data frame. That is a type of the data, a structure of the data, and it has got the length 5, means 5 columns are there, and the size is here, and the observations are 50 and 5 variables. And here there is a small, you know, Excel or spreadsheet kind of icon here, and if you click on that, it will take us to the viewer pane. Okay. Fine. So there are a lot of you know, a bunch of functions in R for data wrangling, just to you know, retrieve the names, just to, you know, manipulate the data in the sense of clean the data. Okay. So if you want to get the names, you can give the names EX1. Okay. So you'll get the column names of the, you know, particular data frame. Okay. And if you want to find out what is the length of a particular column in that particular data frame, we'll see. And okay, before that, I just want to see, since it is small data, if you type in EX1, you're going to get this one printed within an you know, within a certain limit, the 10. So it is shown as tibble here. As I told you, data frame is taken as tibble. There is some reason for that, which we don't have to worry right now. So it is an 50 by 5, not matrix, but the dimension is 50 by 5, the data frame. And okay, and if you want to retrieve a particular column, what you have to do is, just instead of typing EX1, enter EX1, you need to just cherry pick that one particular column. I want to pick the column called pond. So what I'll do is, you know, after EX1, I will just type this $sign. Okay, so $sign is on the, if you're using a laptop, it is above the number 4, shift and $sign. So once I click it, it gives a pop-up which has all the column names. So I can just, you know, select the pond. Okay, and if I click enter, I'll get all the label, I mean all the labels and levels in the pond. Okay, the same way, what you can do is you can assign this particular, you can create another object called I'll name it as pond, a new object, and I'm saying, like, to the new object, please store my from my EX1 data. So you got a new object here on the right hand side, which is numeric and has 50 observations and contains you know, of these levels and the labels containing the levels of the pond. Fine. So that is one way of doing it. And see, for example, if you have a large data and if you want to find out the what is the length of the number of the length of the pond column, you can just specify it. How to specify? Give EX1 pond. Okay, so you give the get the length 50, and all these operations can be stored. The results can be stored as an object into separate, you know, into the environment. Okay. So, but you know, there are repeating numbers. There are not 50 different ponds. There are only maybe 3 different ponds. How to get the unique numbers, unique levels of the pond? The levels are repeating. This, I've coded this as numbers, but they are actually the classification variables or class variables or the factors. So if you want to get the numbers, we get unique, you know, unique length EX1 pond. Fine. Sorry, I gave it wrong. It should be the length unique values. So just see, if you type unique, okay, and EX1 and pond, 3 different levels. So it means that you have 3 different levels in these 50 observations, 1, 2, and 3, and rest is just repeating 1, 2, and 3 repeating. Okay, if you're familiar with the ANOVA thing. And if you want to get the length of that, it's a length unique ex1 font. Fine, we got 3. And this is just the very basic, things, very basic things what you can do in the R. Just to want to encourage you to look into those aspects if there are total beginners. That's why I'm doing it. We don't have much time. We are running out of the time, so I cannot just spend a lot of time on this. So one thing is I want to show is if you want to see the frequencies of any particular column like ex1 and font. Okay, I have 3 different fonts named as 1, 2, and 3, and I've stocked 17 numbers in the first font, 18 numbers in the second font, and 15 numbers. So the first font is repeating 17 times, second is repeating 18 times, third one is repeating 15 times. So this is a kind of unbalanced data or non-orthogonal data. Okay. The next thing is that we have a lot of data wrangling things. Maybe we'll not be looking into all those things. I'll just show you how to change the name, or if you want to, copy, make a second copy of this ex1 file. Just ex, you want to maybe, so for example, you want to do ex2 file. Okay, just simply assign ex1 to ex2, and if you look at the, I've used this for equal to sign. You can use a less than or hash sign also. So the same data file is created here. And if you want to, in fact, make a new data file with the kind of, data cleaned after cleaning the ex1 and from maintaining the ex1 as such, and if you want to make a new file for the clean data, this is how you're going to do it. And so if you want to, so I'll show you how the indexing works actually. So if you want to see the column names of ex1, fine, you got this column name, and you have 1, 2, 3, 4, and 5 columns. Say for example, the 5th one is body width. Okay, I want to change the name of this body width a label to maybe lowercase letters, BW, or any other, for that matter, any other. So what I can do is I can call for the column names and ex1 and the 5th column. Let's see, it is printing the BW in the capital because it gives you the column name. The same function, if I use for, in the double inverted commas, if I give a like body width and see and try to print the names again, so you're going to get a different one for the body width. Okay. Anyway, I'll just change it back to the original one. So this is how you have to manipulate the data or clean the data. Okay. Maybe we can straight away go to the summary statistics, the descriptive statistics. So if you go on with this, the data wrangling in R itself is like a course. So we will not be able to cover any of the portions. So we'll come to the main thing, the descriptive statistics. So the base R has got some functionalities to find the descriptive statistics. So the very basic functionality is a function known as a summary. So if you type the summary function, and I don't have to type it here, it's already here. So ex1, I'm asking for the summary of the ex1 file, but specifically ex1 data, but specifically like, say for example, head width. Okay. There is some issue with the ex1. Some ex1. Okay. See, think this is a very small data set. I try to get the summary of the the entire data set, but these two things doesn't make any sense, because we know they, even though they are coded as the first font is coded as numbers, but these are not quantitative variables. We represent font as factors or classification variables for the entire data. So what are the quantitative variables which are interested is this HL for headline, throttle length, and body width. So if you see, this gives a very bare minimum basic statistics. It gives the minimum value, first quantile, and then the median, mean, third. I mean, first quantile is like the 25th value, and third is like the 75th one. So and the maximum value, and we cannot get a mod in this one, because and even we don't have any functionality for getting mod. If you want to find a mod, you have to write a small function and get it by yourself. And there are some packages where we can get the mod. Obviously, there is no basic. So if you want to just get the mean, what you can do is x1 and HL. Okay, so if you want to print this basic statistics, not a descriptive one, I mean, the summary is being used, okay, function, and you can get some of the values, some of the very basic information. And if you want to specifically find the mean, you can type, there is a function for the mean. You can get the, if you want to find the mean of the headline values, type the name of the data set and pick particular and get the mean. Okay, in the same way you can get the maybe the median and x1 headline median. Fine. So enough with the basic summary thing, and you can check it by yourself. So what I want to do is how to get a descriptive statistics. So for that, we need to have some package, and there could be many packages, out of which I use a package called the Pastex. Okay, so I think this would be the right time to show you how to download and install a package. So you have in the right lower quadrant, you have a tab for packages. Okay, so it will list out all the packages which I'm having. I might be having already this package, but just to demonstrate how to install for the starters, I mean, there's a small icon which is written as install. Okay, I can just click on this. Fine. And the repository will be the repository from which will be it is connected to is called the CRAN, or Comprehensive R Archive Network. And when you know the name of the package, and how you know the name of the package, you're doing some small research in over the internet, and you type in ask the community, there will be an answer in the community, which is a package used that is required for this statistics. So any keyword you can type in the Google and you can find it out. So you write Pastex, right? And you click the install button, and yeah, so it automatically, this is traditionally how we install the packages. This particular, see, it prompted this particular code, install.packages, and within inverted commas, you're writing Pastex. You can ignore all the warnings. You need to be careful only with the error things. Okay. So now the package is being installed. Okay, so I got the package somewhere in this pane, and now I want to load the package before calling the function within that. So what I'll do is I know the name of the package is Pastex. Okay, I can just, in order to load the package into the environment, I need to check this small window, little window before this. This is a package Pastex, and you have to click open this and see what is happening in the console. The console, R prompts, when I click this, so RStudio is prompting R to load the library Pastex. So, I mean, this is conventionally how we do it. I mean, you type the function library. Library is a function within the R base, okay? And you type the, package name and without an inverted commas. But when you install, if you're typing the code, you need to type in with an inverted comma. Okay, fine. So you have got the different functions within the aspects, and so I want to get the descriptive statistics of any particular, what is that column. So what I will do is I know what is a function because I've already done a small research in internet, and I know somebody has answered me that you can use a function called stat dot des. Okay, so if you see the pop-up, you can see the curly brackets. Within the curly brackets, it shows your library within which this particular package resides in. Okay, click open that, and I want the descriptive statistics from the data ex1 or object ex1, and within that object ex for a column or variable called hl. Okay, it gives you bunch of information here. It gives you both the basic statistics and the descriptive statistics. Some of the information, the relevant information, is like the total number of observation it gives. Okay, so we don't have any null values here, no NAs here. It gives you the minimum and the maximum value and the range. We get the range. Okay, and the total sum of the column also we get 1409, and we get the median, mean, and the standard error of the mean. Okay, and the confidence interval, 95% confidence interval, and the coefficient of variation, and see 95%. It's from for the mean, we get the confidence intervals, and for the standard deviation and the coefficient of variation. So all the descriptive statistics and basic and descriptive statistics you can get with this very basic function. And so there are attributes. So this is one attribute, which attribute means whatever you're typing within the function is called an attribute traditionally. So if there are many, a function might contain a lot of attributes, like, if you want to just get the descriptive statistics in this particular case and not the basic statistics, you can turn off the basic statistics. If you see the line number 101, what I've written here is, data ex1, and I want the column HL from that. And the next argument I've given, and this argument I'm not making it up. This has already been a part of this, what is that function, and how I will find it out. There are two different ways. One is just go inside the library and go to the stat. It is all the functions are will be appearing in the alphabetical order. You go to the particular function, click open that, and it will give you the syntax for that. See, so if you see this, how to use the stat.descriptive, and there is an argument called x. There is another argument called basic equal to true. Okay, whatever it is given after this, these are all default arguments. Okay, so if we use only the x argument in like we have used here, the x in our case is xl. I mean the HL column from the x, the data frame or time. So whatever it is, a data frame or the whatever data we want to apply this function on. The rest is called the default, and this will be run. Okay, so if you want to turn off this basic, you have to write basic equal to false. Okay, and if you want to turn off the descriptive, you can write a descriptive DESC equal to false. If you want to go back and read this, you will understand that. Okay, fine. Okay, and just see, if you see the number of digits given here, it is like almost 1, 2, 3, 4, 5, 6, and 7 digits are given here. So by default, R gives you 7 digits. Okay, and if more than 7 digits, R will automatically, what is that? It will switch to the scientific notation, like 10 to the power. Okay, so you can change the number of digits. Say, for example, if you want to just print 2 digits, what you can, so R has a basic parameter setting. The basic setting, the parameter means basic parameter setting. The number of digits is set to 7 by default in R. If you want to change the parameter setting, how to go into the parameters is, there is an function called options, OP option. Okay, within the option, you can write digit equal to 2. Okay, so I've changed the parameter setting. So this change will be enforced till the next session. Once I quit this R session, the current R session, the parameter value will go to the default settings. Now just see,
what I will get if I type the same, stat.descriptive and the same, same command, the same syntax. So in order to go back to the same syntax, you don't have to type it again. Once you've already typed, just click your up arrow button. So this is the option which I've changed right now. And before that, I use this. Okay. Then now see, you're getting only 2 digits. So this is a more better way of doing it. Okay. And if you want to save this result, you can use something called the sync function. If you want to show that, okay. Sync is a function. I mean, when you use the sync function and after using the sync function and whatever you're using in between the sync function, it will not be shown in the console. Rather, it will go to the particular file which you have given inside the sync function. I will just show you that. SINK. Okay, within the sync function, and I have to give. There are many attributes. The basic attribute which you should give is the file name. Okay, that too within the double inverted commas. Double inverted commas. I'll give descriptive.txt. Fine. Then I type in the previous command. I will not get that output in the console. Then I have to come out of that sync loop. So I have to type sync again. Just sync and click. Now I've come out of that. Now if I'm typing, I'll get the result. So where is my result? So I think it must be in the default working directory, because I've changed the directory to this, and it should show somewhere here. Yeah, if you see at the very bottom, you have a file called disk.txt, and you can click open, you see I've got this one. This is not stored in the environment, rather it is stored in my hard disk. So you can go back to that folder and retrieve these results. Okay. And how to do the descriptive statistics by group. So there is another function called cite function, which I use because this function was there before 3 or 4 years. So I've not changed that one because it's working well with me. So you can get maybe another bunch of good functions as libraries, in fact, for that. And within the cite library, we have describe by function is there. Okay. So if I want to get the descriptive statistics with by pawn or by sex, this is how I have to do it. So descriptive. So I'll call the library site. It is already installed. I'm not going to install it again. So this is the function which I use, library within the bracket site. And okay, it's loading. So when it is loading, you can see a small, when the console is running, you will be seeing a small stop sign here. Okay, that means it is running. So anyway, so what I have to give is, there are 2 basic attributes of among different attributes. You have to give the file name and which column you want for, and which group you want the descriptive statistics by. So this is a describe by. So you have to see, this is a case sensitive language. If it is described and capital BY, you have to give it as such, or else R will not read it. Okay, fine. So you got a bunch of another statistical information. So if you see this, there is we know that already I've shown you how many unique values are there in the pawn, and this is a the pawn has 3 levels. One is labeled as the first level, second level, and third level. And within the first level, there are 17 observations, second level 18 observation, third level 15 observation, and it gives the mean and standard deviation, and the median, the trimmed mean, minimum maximum range, skewness and kurtosis, and standard error finally. So this is how we get the a descriptive status. One way of getting, not how we get, one way of getting it. If I want to do it by the column sex, 2 different groups. So one is male and one stands for female. So sorry, this one stands for female and this one stands for male. Okay, and there are a number of observations. Again, in unbalanced data, there are 28 and 22 observations here. Fine. Okay.
So let's move to the next session, which is maybe we'll try to use some of the functionalities to see how to draw some of the figures. And I know this is, all these things, you need to go back and look and do a little research by yourself. And just remember that this is just for encouraging you to look into all these aspects. Even if I don't use it for some months, I may tend to forget all these things. So for the beginners, I know it is a bit hard, but don't get discouraged. It takes years because R is having a very high or very steep learning curve, unlike other languages, So, okay, for a histogram, okay, okay. So I want to plot a histogram for the head length data from the EX1. So there is a basic functionality called hist, hist. Okay, so this function is used for plotting the histogram. But remember, if you want to plot advanced and very beautiful, graphics, you have ggplot and ggplot2 with infinite options in that. I mean, you get a very beautiful graph of whatever way you want. That is a flexibility of the R. Okay, sometimes you may not be able to appreciate seeing these basic things, but once you move to the advanced things, it's really good. So I want to extract the head length column, and let's see what will happen when I pass this particular function. And I've written something called freq equal to f. So I don't want the frequency distribution. Instead, I want the density distribution. Okay, so by setting freq equal to f, I'm applying the density function to this particular histogram. Okay, let's see what are the results we get. Okay, fine. Let's see. So the distribution is not very good distribution. We expect it to be a normal distribution. There are some kind of outliers you can see, and in the y-axis gives the density, and the x-axis gives you the distribution of the HL, the values of the HL. So see what is happening if you remove this. If I remove freq equal to f, means freq equal to false. F stands for false. Two way you can set the true and false for an attribute. Either you write it entirely, or otherwise you just write the short form f or t. So these are all the things you need to learn, by yourself. Doing and learning is the best thing. Actually, you will run out into different errors, but once you practice it, you'll get all those things. So see, the x-axis the y has changed. So now it is showing the frequency of the bins. Okay, each bins it is showing. Okay, this is a very basic histogram. You can change the color, you can change many things, you can separate the bins, a lot of things you can do in this. Okay, so but to the freq equal to option, just for having an overlapping of a density line, normal density probability plot. Okay, now the next one is I've used a function called lines. Okay, just right after the hist. Okay, and this I want to overlay a normal probability density plot over this histogram, so I'm asking for the lines, but it should give you the density, and na.omit means if I have any missing values, this function will not work. So I have to specify that, okay, if there are any missing values, you need to omit it. So one of the key to learning R is you need to, it's like just logical thing. I mean, you think logically, okay, what you need, what is the requirement, and you just try to get those functions for implementing your thoughts in the computer. That's how you can learn R, the easy way to learn. Okay, so there are three functions compounded within each other, which is a line. I'm calling for the lines, but it should be density. That density is for the probability density function, and I don't want any NAs, because if NA is there, I'm not going to get, and I want for the column H. And LWD is line width. I'm asking the width of the line should be of certain dimension. I've set it to 4. Let's see what you get. Okay, fine. So you got a normal probability plot. This is how actually the theoretical with this particular kind of data, the mean and the variance. This is how the normal probability density function is supposed to be. Okay. There are different plots where you can actually do. There can be a stem. You have and see if you want to change the color. Maybe you can give comma color equal to.
So now, yes. So now the color has changed for this particular
line. So this is how there are a lot of attributes and a lot of functions what you can use. And even for the histogram, let's see how what is the distribution of the total length. And I want to change the color to maybe color equal to blue. So remember, always when you give the color, you have to give in the double bracket, double inverted commas. And how I know? You need to practice, then you'll remember these things.
Key. Okay, fine. You got. I mean, even total length has got the same distribution, and you want to fit a line onto the normal probability density plot of TL onto this histogram. Oh, this something went wrong. What is that? I think. This, yeah, when I wrote this, one bracket was raised. Okay, fine. It did not took the argument red because the red has to be within the lines function. Okay. No.
Okay, so this line, I mean, there is some error is happening here. I don't know why the color is not changing. I think one bracket is missing here.
Anyways, let's don't waste time there. We're getting the plot here, and because it's going to take some time, so don't waste your time. So we'll go. Okay, you go and go back and try how to. Okay, if you don't have this, what is that? Functions, you can just go to the Google and ask Google how to do this, and you will get a very beautiful documentation for doing. I mean, simple things explained by the community. Okay. And if you want to do a box plot for these total line, you can do it. Okay, so I hope you know about this box and whisker plots. So you have the median here, you have the 25th and the 75th quartile, and the whiskers, and these are the minimum and the maximum values. And I don't know, the mean is not shown inside. There are some arguments where you can represent the mean. Okay, so box plot, a simple box plot function can be used for printing the box plot. And see, if you want, I mean, the box plot function you give, and you're asking for an out argument. After giving this $sign, you get some outliers. Maybe outliers are present. I mean, this shows there are no outliers. If outliers are there, if by default they will
appear as the simple circles here. Okay. Okay. So if you want to save the graph, what you have to do is you click open the export button, and you can either save as image or save as PDF. If you open this, save as PDF, you have a lot of options to go to portrait and landscape, and the default path will be your default working directory. Okay, these are the basic graph. Okay, let's maybe we'll just see a test of normality. So in the base, so there is an implementation for the chaperone test, and the function is named as chaperone.test. And if you want to test the
normality of any particular, like for example, the TL. Okay, send this function to the console and let's see what is given. Okay. See, the chaperone will test and the p-value is very high, so we fail to reject the null hypothesis that it says the data is normal. Okay, fine. So in the case, if say for example, we'll just see for the head length, maybe that it may not be normally distributed. HL 0.05. Still coming to the 0.05. Okay, let's assume HL is not normally distributed. I mean, yeah. And if you want to create another column in the EX1, which is a transformed data of HL, how we can create it? I'll just show. So we already have the EX1, and we will just give EX2. I want to create another data called EX2, which contains the EX1 data file plus one more column, which is the log value of the HL from the EX1. So this EX2, I want it as a data frame. So I'm giving data.frame. Okay. So data.frame means I want this object to be saved as data frame. And within that, I want EX1, comma. Then other than that, I want another column called log HW. Okay. Log HW, which is equal to the log value, the natural logarithm value of the HL column from EX1. Okay, so this is how we logically do it, and send it to the console. And we have an EX2 here, and if you click open that, you can see a new column which is the log value of the HW. So sometimes if you want to do a logarithm transformation, if your data is not normally distributed, the same way if you give SQRT, you get a square root transformation. You can do a square root transformation there. Okay, and an arcsine transformation. We don't have a function for doing arcsine transformation directly, so it's the inverse of the sine. So you'll have to write a small function or have to specify the formula for doing it. Okay. So there is in fact another there's a simple way for editing, which is a fix function. If you type in fix and or edit and give the what is that file name inside, to give edit or fix, then give the file name ex2. You may not be able to view that because I'm not sharing that particular. So you're going to get another data editor where you can edit all the data. Okay. And what you do and try and do it in your this one. Okay. So in the console also they will print that. Okay. So the same way, if you're giving a name to this edit function and open and edit in a different editor, the edits will be saved to the new data frame. Fine. So I think maybe we can look into the scatterplot. So there is a simple function which is called plot function. Plot function is generally used for many different plots based on the values you give. So if you want to give what is that? Get a scatter plot, just give the x and y values. I actually I'm not which is x value. We'll just give try to plot a scatter plot between your HTL and HL, the total length and head length. It should give you some very good scatter plot because they both are dependent on each other. I mean, redundant measurement of HL must be a redundant measurement of the TL. So HL and EX1 TL and send it to the console. Okay, yes. So the head length is a part of the total length, so we get a very nice scatter plot, linearly dependent. Yeah, but with some outliers here, okay, at the extreme position, and we can remove these outliers and we can find these outliers. That is altogether a different, that falls in the data wrangling process. Okay, so that is how, and maybe you can change the color equal to so the blue color, so you can change a number of colors is possible, which you need to look in the documentation for what are the different red, purple, many colors are possible. So okay, but this is actually a wrong way of giving it, because in the x-axis the HL has come, the x-axis should be TL, because you know, the HL is dependent on your TL. So that's why I went wrong actually here. So whatever the argument you give at the first position inside the plot goes for the x-axis, and which has given in the second attribute goes for the y-axis. So it should be TL and HL. Okay. Fine. So you get the same thing, because you know, the same either way around. It's a highly linearly dependent data. Okay, so you have that's a scatterplot. So there is a linear dependency. So some measures we can find out. One is if there is a linear dependency, there can be correlation, how much association is there, and there can be you know, regression values we can estimate how much of dependency is there for the one variable on the other. So for the correlation, there's a simple you know, function in R which is called the core.test. Okay, so there are many different ways in which you can specify the this formula. Okay, this argument inside the core.test. Okay, so first argument is called the formula argument, and this particular small thing, like a worm-like thing, is called a tilde. I mean, tilde you can find under your you know, escape button, the second button from your, you know, to the keyboard. I mean the second row, first button. Okay, you know, so that is a tilde, and you have to press a shift. It's an uppercase character. So press your shift, and then you can type this tilde. So tilde means, in fact, it means equal to. Okay, this is one way. In fact, even you can give body weight tilde total length. Okay, so now we want actually the correlations between the TL and the HL from the EX1 data. Method, I want Pearson correlation coefficient. I think the 2 or 3 Kendall's method and the rank correlation could be possible in this. And I want to test at the confidence level of 0.01. Okay, at a p-value. So let's type and see. Okay. So you see that's a Pearson's product moment correlation. You can see the result here in the console. So the association between total length and the TL. And it gives the statistic, the degrees of freedom, and the p-value. See, the p-value is very less. It's almost 0, like 10 to the power minus 16. So you can you have enough evidence to reject the null hypothesis and go to the alternate. The true correlation is not equal to 0. So the null hypothesis in a correlation test is that the correlation is equal to 0. So the alternate hypothesis is significantly different from 0. Okay. So at 1% confidence interval, so you repeat the 100 experiment 100 times. I mean this value, I mean out of 100 times you go wrong only 1 time. So but the value is very, very high. I mean p-value, I mean it's like almost 0, and your correlation is if you have more than 2 variables, you're going to get a correlation matrix, but it is just 2 values, you have 0.98 correlation. Okay, so next you know, linear what is the estimate is regression. Okay, so we'll just see maybe are we running out of the time, sir? I think it's 12:30. Sajid sir, are you there?
Yes, yes. Yeah, Dr. Rameez.
Oh,
Pardon, please. Pardon, please.
Please. Hello.
Yes. Hello. Yeah. Am I
Yeah. Yeah. You are audible, Dr. Rameez.
Yeah. So are we running out of the time? So do I have the time for just showing the linear models? just the regression and ANOVA, or shall I stop with this? Maybe if because it's already 12:30, I had been given only 2 hours.
Our second speaker is ready actually. Dr.
Yeah,
Sajid
yeah. No,
so
no.
I think you finish the regression and ANOVA first.
Okay, just maybe I'll just no, just show the function. Maybe they can go back and see this. Okay, for the regression, we'll see there is a base function in ANOVA, which is LM. In the R, which is called the LM. LM function stands for the linear models. So ANOVA and regression, we can thought about us think with those as to be 2 sides of the same coin, which is a linear model. And ANOVA, we are in the regression, we are trying to model between 2 these variables. Two quantity variables. So we can see regression dot fit between HL, which is a dependent variable, and your total length, which is your independent variable. X1. Okay. So I have stored this data into something called rig.fit, and if I want to see the summary of rig.fit, rig.fit. Okay. So here you can see, I'll just maximize it. This is formula. See, what I did is just use the LM function and give the regression formula, which is your dependent variable tilde, which stands for equal to the TL, okay, regressing HL on the TL and giving the data name, okay. And I try to ask for the summary of this model, okay, which is regression.fit, and I got a bunch of information here, which is important is the regression coefficient, which is a 0.43 here, and the test statistics for that. So the regression coefficient is actually highly significant. So the significant 3 means, I mean, 3 star here means that it's almost 0. Okay, depending upon the value they have given, the probability values, and you'll get an R square value here, an adjusted R square value. Both are almost same because it's not very there are not just only the simple linear regression, so it must be similar. So R square value is given as 97%. So anyway, that is regression, and the same thing you can use for the ANOVA. See, you have I'll type in here only. So I'll just give this model. Okay, I'm using the same LM, and I'm specifying the function. So I want to find the effect of different pawns on the total length, maybe TL tilde pawn, but the pawn is coded as numbers. So I need to make the R understand that they are not numbers, they are levels or factors. So I'll just type in factors and font. Okay, I think font must be capital letters, font and comma the name of the data file. Fine. So I'll just get a summary of the model. Okay. Here you get, I mean, this is not an ANOVA table. Not to get ANOVA table, you have to use another function called ANOVA. Okay, this is not the type 1, you're not the sum of squares table. These are your estimates, actually, the estimates of each level. So you have the pawn level 2 and pawn level 3, but the pawn level 1 is defaultly set to 0. That is how it works. If you know the algebra behind how to estimate, I mean, this is nothing but the what we call as unbiased estimates. Okay, so because of the dependency on this design matrix, 1 will be constrained to 0. If you want to just get the okay, it's not the thing. Maybe ANOVA and model. Okay, this is your I think the type 1 of okay, this is just a one-way ANOVA, so it's same anyway. So this is the sum of squares, this is mean sum of square, and this is a value, this is the probability values. Okay, so these are the degrees of freedom. This is not point 2, this is degrees of freedom. There are 3 points. So -1, there is 2 degrees of freedom, and total 50. So there are 47 degrees of freedom, and it shows the point is having a significant effect on the total length. I think we can stop with that because it's a never-ending thing, and I know it was quite a fast, session. So over to you, Sajid sir.
Thank you very much, sir.
Yeah, sir.
We will take a few questions, sir, from the participants.
Yeah, sure, please.
One question is there from Vijay More, from where all these DOS commands used in R Studio can be available.
Okay, R has got a documentation in the in the CRAN. So see, the thing is, you cannot by heart all these commands. So what you have to do is you need to know what your requirement is. So based on your requirement, you go to the internet, do a search, and you will get those. I mean, that's why actually we say the active community. I mean, the R. I mean, you think of any possible questions you can think of and type in the internet, you'll get the answer for that. I mean, the people, they are hugely using R, heavily using R. Okay, so that's the way you can get it. And if you want to get all these functions, I mean, go to the CRAN, CRAN, and you type in just the basic functions available, the functions in the base R. Okay, but that's not the best way. The best way is not to get the functions directly. The best way is to understand what you need and do a search based on that. Okay.
One more question is there, Doctor. Miss Anju Bhagat is asking that can you explain how to do Markov chain analysis?
Markov chain analysis, I mean, it's an altogether, I mean, requires a lot of time to explain those things. I think that's out of the scope of the present session.
Okay.
That's yeah. Anything else?
Yeah. Graphical, already you explained how to draw the graph.
These are the very basic graphs, I don't, but I would recommend you to go and read about the documentations on ggplot based on your requirements. That is one of the best I mean libraries, I mean in vogue, which is used by the people who use R.
Srinivas Das is asking how to cite R in our paper.
Okay, great. That's a good question. I mean, just you see citation. Okay, this is how you have to cite R in your paper. Just you do one thing. See, you have a function called citation, 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 and just no need to give any attributes. Just type in that value in the console, and you're going to get the output here. So this is how you have to, it changes from every year. I mean, the date changes. I mean, this year changes. Through. I mean, every year they release new and new. What is that? Versions of R. So it changes. So this is how you have to, cite it, and you get Dept and latex users. You have got their format here. So this is how you have to cite it. So it's clearly given here. Okay, I hope
Somebody is asking about explain data envelope analysis.
Data envelope. I'm not data envelope analysis. I'm sorry, I'm not sure about that.
Maybe the wrongly spell.
Yeah, maybe I'm not sure what actually that means.
So, Dr. Rameez, I think we should stop here.
Yeah, definitely, sir.
We really enjoyed your nice presentation.
Oh, thank you so much.
Most of the participants, they are sending their feedback like they are very happy to learn this R.
Good. Okay. I mean, good to know that, sir. Thank you so much for giving this opportunity.
And, we are very much thankful to you also.
Yeah, I know this is
college and
yeah.
Yes.
There's very less time actually, sir. You know that how difficult.
Yeah. It's a big issue. Yeah.
It's a big thing actually. You need and even if you want to do a hands-on session, I think not more than 25 participants are desirable in this session.
Okay.
Otherwise you cannot attend.
But you explain the R now around 250 persons.
So yes, 250. That's I was actually the numbers when the beginning. It was quite intimidating for me. 225.
Thank you very much.
Thank you, sir. I think then with your permission, may I leave?
Yeah, please.
Okay.